Hello friend, welcome to Marine Engineering Hub. Today I am going to explain about the semi-built crankshaft and the fully welded crankshaft. In my earlier video, if you have not watched, I have explained the forged type and fully built type, and this is a continuation part 2. I will explain the semi-built and the fully welded. In semi-built crankshaft, basically the crank wave and the crank pin is been forged, and or you can say it is casted and then machined, and the main journal is been made separately by forging method, and after that it is been assembled. As you can see, because the crank wave and journal is a single structure, therefore the grain flow is continuous, and hence as the grain flow is continuous, the structural strength to withstand high gas load for semi-built crankshaft is very good compared to the fully built. The next thing is that the journal is been shrunk fitted to the crank wave, and as you can see, the diameter of the journal is increased so that to prevent any hoop stress building on the bearing surface, and moreover to reduce the weight of the journal, a hole thorough is been drilled so that the weight is been reduced. And moreover, as you can see, the journal is been designed here, the design is been slanted so that the weight reduction can also be incorporated, means the wave design is been changed little bit compared to the conventional one. As you can see, in conventional one the wave design, and here you can see the wave design is been changed so that, and have a little slanted structure so that the weight can be reduced, overall weight can be reduced first. Second thing is a continuous grain flow is being provided, and to prevent any stress raising, the end parts where the ends part is been coldly rolled so that to prevent as a stress razor, and moreover by cold rolling method we are basically removing any stress, and we are implementing the compressive stress, residual compressive stress, which is adding the strength of the semi-built crankshaft. Okay, so as I have told you, in semi-built crankshaft the wave and crank pin are made from forging or a steel casting. The journal are machined from forging. The crankshaft is made up by shrink fitting the wave on the journal. I have told you here in this, as you can see, this is a wave and this is a journal. This is a wave and this is a journal. Now this wave is being heated up and this journal is going to be fitted by shrunk fitting method, and after assembling it will look like this here in this photo, as you can see. Okay, let's move next. What are the advantage of semi built up crankshaft? The first thing is that it is lighter than the fully built crankshaft. Why it is lighter than the fully built crankshaft? Because of the modification of design. The second is the continuous grain throughout the forging together with cold radii give increased strength. Okay, the third one is crankshaft is able to take higher gas load and hence can withstand higher shear stress and bending stress. Because of the continuous grain structure, the crankshaft is able to take the higher gas load, and therefore it can be implemented on a high power engine. Now we are moving to the welded type crankshaft. In welded type crankshaft, the whole assembly, the half of the journal, please listen carefully, this is the half of the journal, the crank wave and the crank pin, fully crank pin and half of the journal on each side is been made up in a single casting method, and after that it is been attached to the other part which is been made in same way, to the other part which is made in same way by submerged arc welding method. Basically here in welded crankshaft the journal is been made in half way, and after that it is been attached through a submerged arc welding method. Why it is been done so? It has been done so because in welded crankshaft have a much more advantage over the semi built, because the whole structure is been singly casted and therefore more continuous grain structure flow. Second, as the journal pin here, as you can, as a journal pin is not shrunk fitted, therefore there is not any chances of slippage. Okay, now the third thing is that as the overlap, there is a overlap in the journal pin, therefore which provide increase in the bearing load capacity and hence able to take higher stress. And last thing is that shaft have a higher natural frequency of torsional vibration which improve design. Okay, so first thing, what are the advantage of welded crankshaft? The advantage of welded crankshaft is that it have a continuous structure, so increase in strength and hence can take higher load. The second thing is that as the shrunk fit is not been implemented, therefore it reduced any chances of slippage. The third thing is that the overlapping is been done while the welding method, so therefore it increase the overall bearing surface area and hence it provide higher load carrying capacity. And the fourth most thing is that each material have its own natural frequency. The natural frequency of the shaft which is welded one have a higher, and therefore a torsional vibration is much more reduced. Now, though it has many advantage, the welded crankshaft, though it has many advantage, the whole process is very expensive, and therefore this welded crankshaft design is technically very good, but it has been discontinued and it is no more further implemented because it is too expensive to carry out. Means that the design has no flaw, it has everything what what you want in a crankshaft, but because of its too expensiveness it has been discarded by MAN BMW in 1980. All the crankshaft which has been fully welded which has been made has not have a single failure and it has a high fatigue life. Okay friend, thank you for watching my video. Please do like, subscribe my video. Thank you.